Hello and welcome back to Data Science Castnet. In today's video, I'd like to talk about video stylization with diffusion models. We'll look at some of the existing techniques that have been around for a little while. We'll see the problems with them. I'll propose a new solution for some of those, and then we'll look at Runway ML's new paper where they developed their GEN1 system, kind of state-of-the-art video stylization model, and we'll see how those compare. Let's start by defining the problem. We'd like to take in an input video and transform it somehow, ideally just by typing in a text prompt or providing a reference image for how we'd like to change the style. We've been able to do this for some time with images, right? Even things like image to image, where we take an image, we add some noise to it, and then we denoise with a new prompt, is able to transform an input image by changing the style and so on. However, if we apply this to a sequence of frames in a video, we end up with a flickery mess. So we need some way to fix that. So for video stylization to work, we actually need three things. We need control over the style, the transformation, how we are doing this shift or this stylization. And we also need to keep the content of the original video. So we need the motion and the structure of the driving video, otherwise it just gets lost. And finally, we need consistency across frames so that we don't have this flickery, jittery mess, but we have something that's reasonably consistent frame to frame that looks nice and smooth. So we'll look at some different ways to tackle all of these challenges, starting with the simplest and the worst, the basic image to image. So for image to image, we can vary the straight, that is how much noise we add and how far we denoise again. And so we can keep this fairly low if we'd like the video to be more consistent, but then we can't make such a big change. So we lose that control over the stylization. Or we can use a higher strength, but then we lose the consistency. So one way you can get around this is to only stylize individual keyframes, right? So you have maybe one frame every second or something like that, and then use other tools such as EBSynth, example-based synthesis, to shift those frames according to the driving video. And so here I have some examples where we've synced the keyframes to the beat to get away with the drastic shifts a little bit more. And you can see it's a little bit more consistent within those windows, but it's still flickery and blurry and not ideal. This is partly because the image to image doesn't necessarily keep the original structure of the input video. So how can we fix that? Well, next we can do something called depth to image, where we have some additional controlling input that helps define the structure of the generated image, independent of the kind of image to image process. And so this is really great. It lets you have something that's much more consistent with the input video structure, which we can then use with EBSynth. And you can see that myself and others have had some success using this to stylize video, again, combining with techniques like EBSynth to avoid the flicker. A more recent model that's really great for this is Instruct Pix to Pix. Now, I covered this in a previous video, but just to recap, in addition to passing in our noisy image during the generation process, we also feed in our reference image, our input image, and it's able to take the structure of this and really finally preserve it. And so this is great. And even without any modifications, it turns out that Instruct Pix to Pix works fairly well for stylizing video. Here's some examples from myself and some from the internet. Okay, but it's still fairly flickery, especially if you don't fix the noise. So we need still to address this issue of consistency. And so this is where I've come up with a new approach that adds something called guidance to the generation process with Instruct Pix to Pix. Specifically, I use EBSynth just to predict the next frame according to the current stylized frame. So it takes in the current frame and the next frame of the driving video, the current frame that's been stylized already, and predicts the next stylized frame. Then when I'm generating the next frame, I have this additional loss, this guidance loss, that compares the generated result with the predicted frame from EBSynth. And so this just helps penalize any drastic changes frame to frame, and definitely seems to improve the overall consistency. You can see here's without, here's with, definitely a lot smoother and less flickery. And combining this with fixing the noise and doing some other tricks, maybe some post-processing, I really think is a promising approach to having more consistency with this Instruct Pix to Pix video approach. So I'll share some code below if you'd like to try this yourself. But also, even without that, there's already this GIF-to-GIF functionality in Automatic and some Hugging-based spaces and notebooks that just use vanilla Instruct Pix to Pix. And because it keeps the structure, at least, this seems to work reasonably well compared to any of the past approaches to stylizing video. Okay, so that's kind of a map of where we are at the moment. Next, I'd like to look at this new model from Runway ML. So we're going to dive into the paper and see how they tackle these challenges and what we can learn from that. I'm going to try not to go too in-depth, but we will be taking a look at some of the main techniques. So this is the paper, Structure and Content Guided Video Synthesis with Diffusion Models. And one downside of it being a PDF is that this is all about video. So I also recommend checking out the website where they have lots and lots of before and after comparisons and examples of their new methods in action. So do spend some time there looking at all the examples and the different modes that they have. But we're going to focus on the paper, and we just want to run through and see how they tackled the specific challenges associated with video that we've talked about so far. So they're presenting their structure and content guided video diffusion models that edits videos based on visual or textual descriptions of the desired output, exactly what we'd like. A lot of background and preamble for the related work, and then this is the core, this is the main architecture. And so unlike us where we've been processing so far frame by frame, they're going to take in a whole video at once, or at least some number of frames, I think 8 frames by default. And they're going to feed this through an autoencoder, like the autoencoder used in Stable Diffusion. They're going to do some diffusion in that latent space. So this is latent diffusion, and that's going to be generating the frames somehow. And so by default, you could say, oh, we just feed in the frame and some description, we try and recreate it. That would be like basic Stable Diffusion. Here, they're going to do some extra things. So first of all, they're going to use a depth estimation model called Midas that's going to extract a depth map, this kind of grayscale representation of how far away different pixels in the image are from the camera. And they're going to use that as the structure representation. So they say we extract a structure representation S by encoding depth maps obtained with Midas. So for each frame, the diffusion model is going to have this depth map as a hint for what that frame is going to look like. They also have a content representation, C, by encoding one of the frames with clip. So one of the frames is going to be encoded with the clip image encoder, and you'll get an image embedding. That's going to be some sort of rich vector that captures, hopefully, the essence of that image without necessarily having too much information. And so this is the kind of like style or the content representation, they call it. But this is saying here's one frame, and the same content representation C is going to be used for all of the frames. So it needs to learn from an example image, basically, how to stylize the video in that way. And then at inference, we take in our video, we get our depth maps using Midas, and then instead of having the original video generate our conditioning C, the content representation, this instead comes from our own example image or our own text description, which we can map to the equivalent of an image embedding using this text to image prior. And so we're going to say, here's my original video, and I'd like the structure from that, so I'll use this depth maps from the original video. But for my style, like what I'd like the actual look to be, here's an example image or a text description, and we'll turn that into this conditioning C and use that to do the sampling. That's the technique in a nutshell, but there are some cool things about it. Specifically, let's look a little bit at how they deal with the video aspect. So normally latent diffusion models we've seen operating on images, but in this case they extend it by replacing the normal res block and the normal attention block with these temporal versions. So they have a temporal or a spatiotemporal ResNet block where they add these 1D temporal convolutions, and a spatiotemporal attention block where they have this little yellow addition over the normal one, the 1D temporal attention. And so to summarize what this is doing, say we have a stack of, say, 8 video frames. Normally we have self-attention, which is going to attend to other locations within that given image. This still has that, but then it also has this temporal attention where every location is going to attend to that same location, but from other frames in the video, so different times. And that's what's meant by the temporal attention. Similarly for the convolution, instead of convolving across space like a 3x3 kernel, you're going to have some weights that look at the inputs from different times, multiply those by different scalars. So it's going to be like a 1D convolution, but across the channels, not just of this particular time frame, but all the other time frames as well. And so that's their key insight here, is they've adapted the model to be focused on video, to work with a number of frames, and to have this spatiotemporal component where when generating a single frame, it's incorporating information from the adjacent frames via that spatiotemporal convolution and attention. So it's able to look at the next and the previous frames as they're also being generated to make sure that it's consistent. They also do this clever trick where they are able to train it. So they train it sometimes as an image model on a single frame and sometimes on a sequence of frames with this video approach. And by kind of trading off these models, they can control how much it focuses on the temporal consistency versus the individual like image stylization. And so you get this really nice trade-off of, as you increase this parameter omega here that they have to control this temporal guidance scale, you get better and better consistency frame to frame, which they measure by looking at one frame and then the next frame, which is just the previous frame warped with optical flow, very similar to how we're warping the previous frame with EBSynth. So that error decreases, right? It gets better at keeping consistent frame to frame, but at the same time, then we lose how much we're following the style. And so we can have a very high temporal consistency by increasing this scale, and we get a lower error frame to frame, lower this MSE here, temporal error, but we're not going to be as consistent with the style prompt or the style image that we pass in. And so that's a kind of trade-off, but it's nice to have that explicitly under their control. And that's what enables them to have such smooth videos relative to the frame-by-frame approaches that we've seen elsewhere. And this is kind of what we're approximating with our inference time guidance, where again, we're also saying, well, let's look at the error based on this flow-based, or in our case, EBSynth-based prediction of the next frame. Let's try and minimize that, even if it means we don't follow the prompt as well. So we also kind of have that control with the guidance scale, but up until now, that isn't something that's really been available. So they do some extensions. One that I really like and one that I've used as well is just using masking. So you can apply this only within a mask, and this mask can be generated with Runway's green screen tools or with an open source segmentation model. And then you say, okay, outside of this masked area or inside of the masked area, depending on which way you treat it, we'd like to keep everything the same as the input video. And so you're not editing, say, your character at all, you're only editing the background. And you can do this with the instruct pix-to-pix version as well. You just replace the latence outside of some mask with the original latence noise to the same time step value as you're denoising. And so that gives a nice little bit of extra control. And also you can imagine that someone who's actually using this, you can do all of your normal compositing tricks. So maybe you stylize a whole video, but then you use a mask to use a different stylized version for maybe the buildings were stylized in a different pass, maybe the character was stylized in a different pass, and you can use these automatic green screen tools or some hand-drawn masks to blend between those and to do some extra temporal processing where you smooth everything out, maybe you upscale the video. So there's lots of stuff that can be done in post-processing as well. But anyway, I really like this paper. They show how you've got lots of different ways that you can control. I like the fact that they have the image prompt as the default, and then if you want a text prompt, it's kind of using this text embedding to image embedding prior that's been around for a little while, very similar to how DALL-E 2 works. Yeah, so very nice. Definitely go check out the results. I'm looking forward to this being available to everyone. At the moment, it's only limited access. Oh, but one final cool thing that they show is that similar to how Dream Booth biases like Stable Diffusion to being able to generate a specific style or object, you can do something like Dream Booth where you fine-tune on a small set of images. So here they have these images around the edge by some artist. Those are used to train the model to like almost overfit to those images. And then you can stylize a video using that fine-tuned model to get even more control over the type of style that you want. So very, very nice demo there of the kind of Dream Booth fine-tuning approach to getting even more control. And I guess the equivalent would be if you fine-tuned instruct pix-to-pix or something like it on some small number of images, or you used base Stable Diffusion but Dream Boothed on some specific set of styles that you would like in your video. You could do something like this as well. So that's the Gen 1 paper in a nutshell. Like I said, very exciting, very powerful, and nice to see people using this kind of video first approach where you actually incorporate the idea of multiple frames at once into the model, but also quite interesting to see their choices. So using depth as the way to get structure, you could imagine something like the ControlNet paper recently using instead edge detection or something like that. So there's different ways that you could do that, but they chose depth. We're choosing the instruct pix-to-pix model, which by default has the original image as a reference. And then as your way of passing in the image, like control over what you want it to look like, they have the clip image embedding. We've been using the Stable Diffusion instruct pix-to-pix prompt. And for temporal coherence, they have their multiple frames at once with this temporal attention and temporal 1D convolution. We've been using guidance to do that same thing. So nice to compare and contrast. Let's end with some final thoughts. So several years ago, I was experimenting with this kind of video stylization, and in those days using Clip and VQGAN, and I really had to do a ton of work with EB-Synth and optical flow and all of these custom tweaks where I do some, per frame customized number of iterations depending on how much change there'd been from the previous frame, and all these other, it's like hundreds of lines of code that I would tweak and change and play with to get these results that I'm showing, which are pretty cool, but it really felt like I was pushing right up against the limits of what was possible and nothing was ever going to look particularly good. Whereas now, today, it still feels early, there's still those glitches and things to iron out, but at the same time I get the sense that we're moving into this new era of video stylization and seamless video editing, where we can just use natural language. We have these systems that are better optimized to give you the control, to give you the coherence, and just to, put a lot more power into the hands of creators who are wanting to do interesting and creative things with video. So I'm very excited to see where this goes. I'd love to see what you make. I've linked a notebook down below where you can try out my method, or you can sign up for the waitlist to get on Runway's new Gen 1 system. But whatever it is, if you make something fun, please let me know. Otherwise, I'll see you in the next video.